If you accidentally fall into a black hole, what kind of shocking sight will you see? The truth may subvert your understanding. In fact, black holes themselves are not blackened. Not a hole either. In Einstein's general theory of relativity, a black hole is a space-time curvature so large that even light, an object that cannot escape from its event horizon. And now, we're going to take a spaceship to a black hole and take a fantastic journey through a black hole. When the spaceship approached, we jumped out of the cabin. Begin to approach the black hole under the gravitational pull of the black hole. But before that, we have to wear a special spacesuit. This is because black holes are extremely massive. Its gravity is equivalent to mass, millions of suns, so that all the surrounding stars and matter, all captured by it, and formed a very thick plasma accretion disk. What's even more frightening is, they spin at a speed close to the speed of light. Under constant friction, the surface temperature of the accretion disk can even reach hundreds of millions of degrees Celsius. It also produces intense and deadly radiation. If you're not wearing a spacesuit, be instantly evaporated by it. Interestingly, if you filter across the entire electromagnetic spectrum, after removing all light except visible light, you will find that the spectrum disk shows higher energy blue. The black hole photos previously released by NASA shows bright orange. This also means they only represent bright colors, rather than the true color in visible light. This is a good explanation. Why do hotter stars emits a weird blue light? What's even stranger is, one side of the accretion disk appears to be smaller than the other, brighter. In fact, this is due to the distribution of matter in the disk, movement very fast. The right side is approaching us on the highway, so that all light waves are superimposed together, so it looks brighter. And the left side is moving away from us at high speed, thus causing the light waves to be stretched, so that it looks darker. This is the magical Doppler effect. If you observe carefully, it will also be found behind the accretion disk. Distortion occurred, like it's folded around a black hole. In fact, this is due to the strong gravity of the black hole. Bend the light, like a gravitational lens, so that when we look in a certain direction, the position you see is actually lower. At the same time, we'll also find the stars ahead. It seems to be turning slightly blue. This is because the strong gravity of the black hole distorts surrounding space and time around us longer than time slows down for distant stars. From our perspective, the light from the star is speeding up. This resulted in the blue shift phenomenon. And as we approach the black hole, you will see strange light aberrations. In other words, the black hole seems to be moving away from us. The reason for this phenomenon is, although we receive from different directions, light emitted by accretion disk, but because we are getting closer to the black hole, so that the light in front is constantly shrinking. As we gradually accelerate towards the black hole, as the speed increases, the light ahead also looks brighter and brighter. But the light from behind is difficult to reach in front of you, so it gets darker and darker. This is actually the Doppler effect, the phenomenon caused. If you look at the spacecraft in orbit at this moment, you will be surprised to find the clock inside the spaceship. It also runs slower than before. This is because the signal emitted by the spacecraft every second takes longer to be received. And then we pass through the accretion disk. At this moment, the disk will gradually change from disappeared from our sight. As gravity increases, all matter here will no longer orbiting a black hole stably.
Instead, it begins to spin faster and is sucked into the black hole.
About 2 minutes later, we've arrived near the black hole's photon layer. In this area, any light coming from outside, doomed to fall into a black hole. And as we get closer and closer to the black hole, people far away on the spacecraft will see our images fade and slow down until it disappears from sight. In the next few seconds, we arrived after entering the photon layer, black hole event horizon. Also starting from this moment, beyond the horizon will forever be our past. Everything about us will be with this universe. No more relationship. Even if you send a signal to the outside world, the signal cannot escape the black hole and reach its destination. So when we pass through the black hole, what will you see again? In fact, at this moment we can still receive light from the universe. You can even see spacecraft outside the black hole. So we don't even realize already crossed the horizon. Although on a large scale, the gravitational pull of a black hole is enough to pull it, isolated from the inside. But at a local scale, space-time is almost completely flat, and the curvature is not obvious, so we don't feel it. Changes caused by the curvature of space and time, and due to the strange light aberration phenomenon, even if we are already in a black hole, it won't be completely dark in front of you. Instead, the image of a black hole only occupies 15% of forward field of view. In the area surrounding the black hole, it is still possible. See the starry sky. And in the next time, how fast we fall into the center of a black hole will be faster and faster. Even the light behind seems to. They are all shrinking in the field of vision ahead of us. As the field of view ahead shrinks, the view behind will become wider and wider. The spacecraft far outside the black hole is also there. The field of vision is getting bigger and bigger, even if we are getting further and further away from it. The moment we reach the center of the black hole, you will feel an incredible, the powerful force is tearing the body apart. The moment before we are conscious, you will feel yourself falling into, on a dark, flat surface. Within the next 0.1 seconds, our bodies and consciousness will all be shattered into pieces, entering the center of a black hole. For us, this black hole journey ends here. But for a spacecraft outside a black hole, we will always live within the horizon. In fact, including modern physics, falling into a black hole still unexplained. What happens? However, current theory holds that the center of a black hole is a space-time curvature, infinite singularity. Of course, there are also scientists who question the singularity does not actually exist. Perhaps we are the only ones who combine gravity and quantum mechanics. After unification, only then will the ultimate mystery be completely unlocked.